In this lesson, our goal is to be able to add and subtract polynomial expressions. So first we need to know what is a polynomial and what are the requirements for a polynomial. We know a polynomial is coming from the term poly, meaning many, and nomial, meaning terms. So it means many terms. A polynomial can have constants, variables, and exponents, but only whole numbers are allowed. They can be combined using addition, subtraction, and multiplication, the terms, and division, except not division by a variable. So again, constants, variables, and exponents that are whole numbers. The terms can be combined by using addition, subtraction, multiplication, and division, just not division by a variable. So we have some expressions for you. We want to determine which of those can represent a polynomial. So I'll give you a moment here. Why don't you circle your polynomial expressions and then we'll check. So we can see we've got 7 polynomial expressions. The ones that were excluded, like 3xy to the second, that was excluded because the exponent is a negative number, right? It wasn't a whole number. The square root of x was excluded because the radical, remember, that's also our exponent of 1/2. And again, an exponent of 1/2, that is not a whole number, that's why it's excluded. Our third one, 2 divided by x minus 1, we're here dividing by a variable in that denominator, and that's why that term was excluded. When we talk about polynomials, there are some specific names for certain types of polynomials. A monomial refers to a one-term polynomial, binomial refers to a two-term polynomial, and a trinomial refers to a three-term polynomial. So how can you remember the names? Think of your cycles. Monocycle or unicycle, that's one term. Bicycle, 2 terms. Tricycle, 3 terms, right? 3 wheels and 3 terms. There are also special names for 4 terms and 5 terms, the quadrinomial and quintinomial, but those typically are not used. You do see the special terms names used for monomial, binomial, and trinomial a lot in mathematics. So again, polynomials are typically written in standard form, from the highest degree to the constant term. The degree of the polynomial is the highest exponent value, and the leading coefficient is a number multiplied by the variable of that highest degree. So here we have a polynomial 3x squared plus 12x plus 2x to the 6th plus 15 plus a negative 8x to the 5th plus 9x to the 4th. This polynomial is not written in standard form. Can you write it in standard form? Well, to write this in standard form, we want to make sure we're following the rules, right? We want to find the highest degree, and the degree refers to the highest exponent. So in this polynomial, our highest exponent is a 6. So that should be the first term of our polynomial. And we're going to write it in order from that. So if I have an exponent of a 6, my next one should be the one below that, x to the 5th, then one below that to the 4th, 3rd, 2nd, 1st, and then our constant. So if you're writing your polynomial in standard form, and we go to check, it should look like the 2x to the 6th minus 8x to the 5th plus 9x to the 4th plus 3x to the 2nd plus 12x plus 15. Notice how that term that said negative 8x to the 5th, we just wrote it as a subtraction. We typically are not writing our polynomials using plus and negatives anymore. We're going to use a subtraction instead. Now that the polynomial is written in standard form, we wanted to answer questions about the degree, the leading coefficient, the constant, and the number of terms. So again, our degree we said was 6, right? That's the highest degree of our polynomial. The leading coefficient is the number in front of the variable for that term. So our leading coefficient here is 2. How many terms does the polynomial have? Well, each of these items here are terms, and so if we counted them up, we have 6 terms. The constant is the number that's either being added or subtracted in your polynomial. So right here at the end, the 15 is the constant. So now that we know what a polynomial is, we know how to write it into standard form and identify the key features of the degree, leading coefficient, number of terms, and the constant. We're going to look to see if we can add those items in while we're doing some operations with the polynomials. So what we want to do is add the two polynomials together. So we have a polynomial here on the left and a polynomial here on the right. So again, when we're adding, we look for like terms. And so we could rearrange our polynomials to put those like terms together. And those like terms are typically the degree of the polynomial term. So if you look, both polynomials had a degree of 2, a degree of 1, and some constants. So I just rewrote the polynomials, grouping those items together. Now we're going to simplify. So negative 3n squared plus n squared, that means I would have a negative 2n squared. 2n and 5n, that's 7n. Negative 8 and 13, that would be 5. And again, you always want to double check, is your expression in standard form? Highest degree to the constant. So what's the degree of our polynomial? Our degree is 2. What's the leading coefficient of the polynomial? That would be negative 2. How many terms does the polynomial have? 1, 2, 3. And what's your constant right here of 5? Here's another expression we want to simplify, and this time we are subtracting polynomials. So we have to remember, subtracting means you're doing the opposite. So everything in this second polynomial should be the opposite of what it seems. This is no longer a positive 4y to the third, it's a negative. This is no longer a positive 3y to the second, it's negative. This is no longer a negative 7, it's a positive 7. Once I have that in mind, I'm going to look to see grouping my like terms together. So looking at the degree of the term and matching those up. So I can see I have some powers of 3s, then I have a power of 2, a 1, and some constants. And then I'm going to simplify by adding my like terms. So negative 4y to the third and negative 4y to the third, that would be negative 8y to the third. No like terms for my y to the second power, no like terms for my y to the first power, but I do have like terms for my constants, which would be 17. So my polynomial in standard form would be negative 8y to the third minus 3y to the second minus y plus 17. So if I look at these key features, the degree of my polynomial is 3. The leading coefficient, negative 8. Number of terms, 4. My constant, 17. Let's try simplifying this expression. We're adding the polynomials together. So again, we're looking to see the like terms grouped together and combined. So I have two ab squared terms to put together, two ab terms to put together, and the constant is alone. So we have 7ab squared minus 5ab plus 4. The degree of our polynomial is to the second. Our leading coefficient is 7. We have 3 terms, and our constant is 4. Now that we're used to simplifying our polynomials by adding and subtracting, let's see if we continue on here and find the errors of what happened with these simplified polynomials and talk about the degree, leading coefficient, number of terms, and constants. So here we are supposed to be adding the two polynomials together, and a result was given of negative 2x to the third plus 4x squared plus 1. We know that this is not the correct simplified result. So could you find the error? And if so, can you correct it to find the true polynomial result? So looking at the problem, again, we want to look at grouping our like and then simplifying from there. So let's see. I've got a 1x to the third, a negative 3x to the third. That would give me a negative 2x to the third. Only term here with x to the second, so I leave that as is. Only term here with just an x, and I have some constants of negative 2 and 3, which gives me a 1. So what was the error? The error is this person combined unlike terms together to get that positive 4x to the second. Now, if we talk about the key features, what's the degree of our polynomial? Our degree is 3. The leading coefficient would be -2. We have 4 terms, and the constant is 1. Let's try another. Here we want to subtract the polynomials. So again, this person did it and got 4x squared minus 2x minus 2, which we know is not the correct result. Could you find the error and then show us what the correct result should be? Now, because we're subtracting, remember that subtraction means take the opposite of what you have in the second polynomial. So this 2x squared is no longer positive, it's negative. This 3x is no longer positive, it's negative. This -2 is now positive, okay? And so what we do is now we're going to start trying to group them together, the like terms, and see if we can simplify. So we've got the x squareds here, so we'll have 4x squared. We have the x's here, which would be a -8x, and 2 is the constant alone. So the error was not taking the opposite of the second polynomial to start, and that affected when you were combining your like terms. Now that we have the polynomial in standard form, the degree of the polynomial is 2. The leading coefficient is 4. Your number of terms is 3, and your constant is 2. So that's our practice today for working with adding and subtracting your polynomials, putting them into standard form, and then talking about their key features of the degree, leading coefficient, number of terms, and the constant.